few years ago, I had opportunity to come up with a proof of concept for a platform to build managed software SaaS on. And I did that under the name of something called Machine Room as part of Choria. I didn't have a lot of time to revisit that since. I now have an opportunity to look into it again, and I want to do a quick demo of how that looks. The basic idea is you want to be a SaaS where someone comes and buys software from you, and the way you deliver that software is as managed software, be it on hardware that you manage. Essentially, it's a way to cookie cutter build customers out, or maybe even on customer managed hardware. And because we want to support customer managed hardware, we really don't want any kind of SSHing. It needs to very, very basically pre-build, auto-install. Everything's got to just happen. And the software on there should be managed in a hands-off, autonomous manner. And so Choria has many capabilities that, if put together in the right combination, would make a composition of software that allows you to build that. And that's what Machine Room is. The basic flow is we're going to have a customer site, and on the customer site we want to manage pieces of software. Could be any software. Could be software that takes clustering and with complex upgrading requirements where you need to do orchestrated rollouts. It could just be single pieces of software like monitoring, really anything. It could even integrate with physical sensors and all this kind of stuff. And what Choria provides is this thing called Machine Room over here. It's an agent that you write as part of your company, as part of your company's deliverable, and it would be something like Acme Inc. agent or something. And it is a vessel on top of which to deploy plugins that manage these pieces of software. The startup process of this is literally you install the RPM, let's say, or the DEB, you put on your credentials, a token that the cloud gives you, and when you start the agent, it must provision, it must download the software, it must own the software, manage the software, observe the software, upgrade the software, downgrade the software, remove everything that needs to be done with that software for life should be done by this components that runs here. And so we also want the site to be autonomous, so that should the connection to the SaaS get severed, the software will keep running. So all these autonomous operations to keep the software going, software crashes, software gets started up again, regular monitoring catch-up, status gatherers, all that kind of stuff has to keep happening even if the site is fully disconnected from the internet. And when the site eventually comes back on, the events, the metadata, the information about what happened while the site was isolated should flow back into the cloud for visibility to your cloud operations team. And so this is a RPC3, no RPC in there, no remote orchestration, fully autonomous, fully self-contained, managed cluster. And the frameworks are there to build software as managed in that manner. Now, from the perspective of your cloud management UI, you have a stream, and that stream, this is your only interaction with the system. Lots of events come out of the managed customer sites into NATS, and desired state goes into NATS, which is what should these machines be. You write into key value store what's the desired state, it replicates over there, it goes to rest on the customer onto a key value store in the customer side, and then the customer side will manage amongst itself how that happens, how you get the desired state onto the machines. Scaling wise, the managed customers can be huge. I mean, we've run this model with 50,000 plus machines per managed customer. And your only interaction is streams and key value stores. To deal with the provisioning of these machines onto your network, there's a provisioning component here called Choria Provisioner. And when these machines start up, that agent, your SaaS agent start up, they reach out here, they present the credential, the provisioner interacts with your cloud backend through APIs, says, I have a new node coming in. This is its ID. This is its credentials. Should I provision it? What customer does it belong to? What kind of, all the kind of settings you wish to encode into it. Its configuration, its credentials. The credential needed to log into the SaaS for the streaming messages coming out. All that kind of stuff gets negotiated during provisioning here. And your cloud backend via a single API owns issuing those credentials, all that kind of stuff. So the Choria provisioning over here is just a facilitator. It can stand standalone. You can run many of them. You can run many of them all over the world. You can even run some inside a customer site if it's unique needs. It's a very flexible component. With a single install of this, we can easily stand up 1,000 machines a minute. So these would be 4 machines in this particular managed cluster. And there's an artifact store, S3, let's say, where the plugins go. So building an agent that has all of these capabilities built into it, and the ability to self-assemble and make their structures, and all of the desired state management that goes with it, all of the kind of hosting for autonomous pieces of management software, this is an extremely complex undertaking, and companies can take years and years and years to build that capability. And I've seen plenty fail. However, Choria has all of these capabilities, and so if we present that into a library for you to build this agent, then this is how it would look. Here I'm building an agent, a SaaS agent, generically named. I give it a name, I give it versions, I give it a key, and if we go back to the picture here, the plugins, the software that we're going to deploy, those are plugins, and that comes from a catalog. And the catalog is signed so that these machines will only take fully approved lists of software to run. And it's the cloud management API that creates the catalog of what to run, signs it, sticks it into a key value store. And this is the key that would allow this particular SaaS to run software. Now there's a number of callbacks you can put here, settings, blah, blah, blah. And the system will basically run forever, do the provisioning, do the downloading of plugins, do the copying of events, replicating of data, all this kind of stuff. It's all taken care of by just this 50 lines of code. And here's an example of a callback where I want to capture some additional information about these machines, maybe something that's unique to my particular use case. And so I drop this callback in here, and now when these machines in the customer site runs and gathers the facts, which happens every minute or so, they will call my custom logic to get additional information that's unique to my domain. And so with this, you compile this. It gives you a binary with like 2 subcommands, no Choria anything, and you can license this however you want because it's using Apache 2 libraries, and you can anything you put in here you can commercially license. So that's it. So I'm going to show you a demo of this functioning. It is a Docker Compose that stands up 4 customer machines, provisioning infrastructure, a SaaS backend NAT server, a MongoDB database, a web dashboard, and I don't have an API here to do the node stuff for now. That's just a static JSON file. It also stands up an artifacts file, and it's going to build all of this stuff, provision all of these nodes, get them onto the network, get them sending data, get them showing up in the dashboard, and ultimately it's going to deploy one piece of software into every machine, and all that the piece of software does is every minute does a echo hello. It's the most basic example of what we can do, but rest assured you can run almost anything inside there. Okay. So let's see. Here we are in the Docker Compose environment, and I'm just going to start it. Now a lot's going to happen. At first you're going to see it's going to build credentials, a bunch of shell scripts, and then just a ton of applications are going to start. I'm not going to try to talk through it all because it's too fast, but at the end it will settle and we'll see the customer machines function. So I don't think I cleaned it correctly. Give me a second. Okay. There we go. So it's creating the credentials and the JWTs for how the machines stand up and all that kind of stuff. And at this point, all 3 machines in the customer site has already been provisioned. They're up, they're running. It's busy copying data into the cloud. The data is going into MongoDB, and desired state is coming out from those machines into the site, and then the site gets the machines to do what they want. And in this case, what they're going to do is download something called an echo agent. We'll see that in just a second. Actually, there we go. So they've gotten the desired state. They've realized they need to deploy this plugin from my artifact store. They're busy setting up internal capability to manage the particular plugin, and that is now going to download the plugin. It's downloaded it. It's extracted it, and here's my application is running. And now at this point, each of the machines is every minute running echo hello world. We can see that in no time at all, after start, in sub 1 minute, I would say, we can go from completely blank customer machines, infrastructure has to be there, we can go from completely blank customer machines to fully software deployed, custom software deployed, custom applications deployed, custom applications fully managed. The machines are visible in a dashboard. We can see they're active, and we can start seeing information about them. Now, as it stands here, this is just facts that refreshes every 5 minutes, so it's not very accurate. However, in a real dashboard, you would pull in. There's a lot of events coming in, and so as a machine is deploying, let's say our Echo Hello World agent, events are coming in saying it's busy deploying it, it's up, it's running. Every time the echo command runs, events are being generated. And you can merge those events in with the state to provide a lot of real-time information here. And you can write plugins that communicate any information you want from customer side to you. All of the communication between customer side to me is essentially buffered. So if we go back to our image over here, if this machine wants to send me a message to the dashboard over there, it goes into this machine first, there spools, that machine will replicate it over to there into a spool where it goes into the database for presentation. So everything is eventually consistent, meaning if this connection is down and events are happening over here, when the connection comes back up, those events will become visible. And so you can merge those event streams with the display, and you can get a real-time information about what's actually happening on the site. Now, once the basic infrastructure is built, all the stuff here on the right-hand side, once you have written this agent, which is really just all of this, your applications are just YAML files. Here is the one that is the echo agent, and all it runs is an exec. Every 30 seconds, it runs hello world. These things get much more complex, and they're a full finite state machine, and the finite state machines within a customer site can communicate with each other. And so, for instance, here we've got this red dot here. Let's assume that was an application using the RAF protocol, and an upgrade would have to be carefully orchestrated in such a way that you take one machine down, you upgrade it, you wait for it to health check, and only then do you move on to the next one. And so you have a rolling upgrade that's safe for the kind of system over the raft. You can do all of that in this YAML file and a couple of shell scripts, or I say shell scripts, I mean that's the easiest. You can write it in any programming language, using any library, using any capability you need. It's a system for managing any kinds of software, or even interact with devices and so forth. And so that's it. You make these things, you package them, you drop the manifest signed into key value bucket, and then just like that, your software is deployed. That's about it. I'm not going to go much deeper into this for the moment. but just a quick overview of a platform to build managed customers.